Shut the door, hold on. Okay, everybody. Last week we talked about these functions, right? How did you do on the quiz? Are there any issues with the quiz? Okay, so we have learned how to, do the graph. If we're given a form like this one, right? How we give a quadratic form. This is called a quadratic equation, okay? So we have gone through this table in, let's see, I would say on the quadratic part, I forgot the alpha number, hold on. The alpha number would be, let's see, we know where we are, don't we? Do we know where we are? We started graphing quadratic. Okay, so these are just introductions of how to graph quadratic. And we graphed some simple forms. Okay, we graphed x squared and we graphed x, 2 times x squared. This is alpha 17, right? So to go back to alpha 17. Okay, let's have a recap. Okay, we have graphed. Okay, we have graphed x squared, 2 times x squared, half x squared, right? And then x squared plus 1, or x squared minus 1. And the last but not least, x plus 1 squared and x minus 1 squared. So now this time when we type these functions, do you think you know how to get the final picture from it? Yes? I hope the answer is yes. Yes, yes, yes. No, no, no. Are you guys with me? Hello? Hello, everybody. No? Yes? Are we good? All right. So when I'm going to bring the picture up here, I think that we have a pretty comprehensive summary, right? How to identify line of symmetry and all of those you're being quizzed on, right? This is the summary that we did last time. Okay, these pictures summarize what we did last time. So now, what we're gonna work with, we're gonna attack number 8 in alpha 17. And this is in a much general form, okay? It's a y, of course, it's a function, okay? It's in the form of ax squared plus bx plus c, provided a is not equal to 0, okay? Here, we need to have some explanation. Okay? What is ABC? Okay? These numbers are called parameters. So what are parameters? A, B, C. Okay? They are called parameters because usually what you will see is that these numbers are given. Okay, examples, right? Suppose that suppose we have a form right? Like 2x squared minus 3x plus 5, right? This will be a rule. This will be a rule. What kind of rule is that? Okay, if you call it a function, of course it's a function. And what kind of rule is that? Well, input x, and this is the rule. So what is this rule? This rule basically says, well, you give me an input. Okay, you give me an input. Here's the rule. Okay, I'm going to take that input, okay, and I multiply that input itself, and then I multiply by 2 with that, you know, a number times itself. And of course, x times x is x squared. We all know that. And then we also subtract 3 times that input you give me and plus 5. And after I'm done all of these operations, which I have fulfilled this function, and I will produce an output. And of course, that output is this function, right? This is the output. So input, output. You can see this is a little more complicated rule than the rule we used to know, which is, you know, like x squared. It's a more complicated rules than each one of these. Okay, but it bears some resemblance for what we know. Okay, so this is called a quadratic function. We call this quadratic function. Okay, we have a name for it. Q-U-A-D-R-A-T-I-C, quadratic function. Okay, this is called a quadratic function. Can you say the word quadratic? Quadratic is a very specific type. It's a very specific type, okay? And then in the remaining sessions, we're going to handle this function. We're going to handle this function. And what happened is that ABC can be any real number. Of course, A cannot be 0. So we're going to come up with a school of functions. For each different set of ABC, you're going to have a new rule. Okay, so for example, in this case, we set A equals to 2, right? B equals to -3, and C equals to 5. We got a rule, okay? In another scenario, I will have a different rule, okay? How do I make that different rule? I may make A equals to 1, and B equals to 4, and C equals to -6. And I will be getting another rule. Okay, so this is gonna be a different rule. This different rule is of course gonna be A equals to 1, B equals to 4, right? And C equals to -6. Okay, so my new rule is gonna make another function, and it's another quadratic function. So you can see every time you're given different triplets of values for ABC, then you get a different function. And it's a different quadratic function, but they're all in the same category, right? This is one quadratic function, this is another quadratic function. They are all called quadratic function. The only difference is that the rule has minor differences in applying the rule. Make sense? So how many quadratic functions do you think we can have? I think we can have as many as you want, right? Because for each different triplets of ABC, you will create a different quadratic function. So this list can go on. This list can go on. Okay, with that understood, okay, so we're gonna start with something simple, and we will come back to this, okay? We will come back to this. So let's take us back to alpha 18. Alpha 18. Okay, so we're gonna take some gradual steps to handle quadratic. Okay, alpha 18, are you guys there? Could you look at alpha 18 from your notes? Alpha 18 says, okay? We want to apply that principle. We want to apply that, you know, the square root of x squared equals to absolute value of x. Okay, and also this guy, right? We've done that. We have done that multiple times. And next, hold on. I think I'm choosing the wrong one. Choose this one. Okay. Oh, sorry. So I'm going to redo this. Okay, make it proper. Okay. So this function we've done multiple times, right? The absolute value of a non-negative number is the same as the number. The absolute value of a negative number is its opposite. Right? So we have done that. And in order to apply this, okay, we want to get familiar with, okay, alpha 18 is to get familiar with what? With perfect squares. Perfect squares. I believe you guys have learned this in elementary algebra, but just in case you have forgotten, okay? So alpha 18 is about that. So alpha 18, we have two tables. So let's look at the first table. The first table is purely review these perfect squares. Can you guys say the word perfect square? Can you say the word perfect square? Can you say the word perfect squares? Can you say that? Perfect squares. What is a perfect square? Well, 1 is a perfect square because 1 can be written as what? 1 squared. Right? That's called perfect square. 4 is a perfect square because 4 can be written as 2 squared. Right? What else is a perfect square? Can you guys give me some more examples of perfect squares? Can you guys give me some examples of perfect squares? What are perfect square? Very good job. 9 is a perfect square. 9 is a perfect square because it can be written as 3 squared. Okay? So this list can go on. Could perfect square be a decimal number or fractions? Absolutely. For example, a quarter is a perfect square because a quarter is 1/2 squared. Right? How about decimal number? For example, 1.69 is a perfect square. It is 1.3 squared. Okay, so perfect square is not limited only to integers. It could be fraction, it could be decimal, it could be anything that can be written as the square of another number, and that number is called perfect squares. Now, that's perfect squares as we knew it in numerical value, that we know the value. But we also have an algebraic form. Algebraic perfect square. Algebraic perfect squares. Okay, so these are single numbers. And you can say, well, arbitrary number a squared is a perfect square. Where a is a number, any number. So you can see we can make a perfect square by simply square the number, right? you square any number, the consequence is going to be a perfect square. Does that make sense? Okay. So now, so just one variable squared, we get a perfect square. And we can also say, oh, x squared is also a perfect square, right? That's a perfect square as well. That's a perfect square as well, okay? Where x is any real number. Okay, so you can make perfect square many ways. But how about we have two numbers in sum? This is also a perfect square. Okay, this is also a perfect square where A and B are any numbers, are any real numbers, are any numbers. Do you guys follow me? Does it look familiar? Then you say, well, if you do A plus B squared is a perfect square, how about A minus B? Of course, A minus B is a perfect square. You can keep going, okay? This is also called a perfect square, perfect square. Then you say, oh, could I do A plus B plus C and make that a perfect square? Right? Of course, okay? Just have one more number in the perfect square. No problem. And the list goes on. The list goes on. But we're not gonna deal with those, okay? Those are just a little too complicated for us for now. We are going to be working with these two kinds. Have you guys seen those before? Have we seen those before? Okay, this is a perfect square. That's a perfect square. Okay, that's a perfect. These two are the typical perfect square we are going to handle in this course. Now, have you guys learned the word of FOIL? Have you guys learned the word FOIL? Have you? Have you learned the word FOIL? Okay, so can you FOIL this? Can you FOIL A plus B squared?
That means simplifying, right?
Right. Basically, it's a way. It's also called expanding. Expand. Okay, so I'm gonna show you. Expand. What does it mean? Is that you're gonna take A plus B, multiply A plus B. That's what square means, right? A number time itself. Okay, it's more like you have x squared, right? And that's x times x. Does that make sense? Right? So now we're gonna replace x by A plus B. Do you guys follow me? So that's square. That's a square. And what do we do? What do we do? I'm going to explain to you the geometric meaning of this. The geometric meaning of this, okay? The geometric meaning of this perfect square, basically you have a perfect square, right? So what you have is A plus B squared, okay? In the earlier example, I'm gonna show you this first of all. Okay, we're gonna start with x squared. We're gonna start x squared. What is the geometric meaning of x squared? The geometric meaning of x squared is a square. It's a square. And what happened is that all sides are the same. All sides are the same. Do you follow me? All sides are the same. And the area of this rectangle, which is a square, okay, the area of the square is x times x, which is x squared. You guys follow me? That's the geometric meaning, okay? Geometric meaning. Okay, geometric meaning. If you go to your kitchen, you have a tiles, right? Anybody have tiles in your kitchen? Your kitchen floor, they're usually, right? I know some people may have a different kind of kitchen floor, but most of our kitchen floor I have seen, they're all like made of little tiles, right? The tiles are usually made of squares. Make sense? So when you do the x squared, it's really, if x is a positive number, right? Of course, in mathematics, x could be a negative number. If x is a positive number, it really means this square. This is the square. And the total material to cover this square is called the area. Okay, I'm covering this entire, piece covered, right? It could be vinyl, it could be hard, right? It could be whatever material. We cover this whole thing. The medium that covers the whole piece is called the area. It's called the area. Does that make sense, everybody? Okay, so that's the meaning of area. Okay, that's the meaning of area. Got it? Okay, so how about what is a plus b squared? What is a plus b squared? Okay, so let me gonna show you. The idea is similar. Okay, the idea is similar. Okay, so what is it? A plus b squared. A plus b squared. Okay, so suppose a is a number, b is a number. Okay, and this much, I'm going to use a different color. Suppose this much is a. Okay, and I'm going to change the color. I'm going to use purple here, and this much is b. So that's a plus b. Right? That's a plus b. And what is a plus b squared? A plus b squared, we're going to make a square with a plus b, right? So this much, the whole thing is a plus b. So what I'm going to do, I'm going to measure a green. Oh, sorry. Never mind. I need to adjust the color. Okay. So I want to make this, I want to do this correctly. Okay. The green piece is A. This is A. Okay. So these two green pieces are the same length. And this one is a purple, A plus B. Okay. So when we're making this, we're making a square out of this. Oops. I'm going to use the green. So this is the green. Can you guys draw this with me? Can you guys draw this with me? And this is the purple. Okay, and the green. I will make some adjustment as needed because my drawing may not be perfect, but we're gonna try that. Okay. So here, this purple is too long and I'm gonna make it just right. This is A plus B squared. So this side is A plus B. Oops. Capital A plus capital B. Okay. Every side is A plus B. And these A plus B. Okay. And the other side, I ran out of space, but it's really A plus B. Everybody with me? The green is the A, the purple is the B. Does everybody follow me? Okay. So, nobody's a colorblind, right? Can you recognize there's a green, there's a purple? Green, purple. So now, A squared plus B squared. So A plus B squared is this much. Okay, is this much. So now what I'm going to do is I'm going to draw some lines. Okay, I'm going to draw the blue lines. Okay, so what I'm going to do is I'm going to draw these blue lines. Okay. The green piece, the two green sides, there's this square, this side, right? That is what? What is that? That is A squared. That's A times A, right? That's A times A. How about this piece with the green and purple? That is AB, A times B, that's the area, right? And this piece is AB as well. How about this purple side? That's a BB. You guys follow me? So the entire A plus B squared, if we divide it into these four pieces according to color, we have A times A plus A times A times B, A times B twice, and B times B. So the total area in this largest square is going to be the same as A times A plus A times B plus another A times B and a plus B times B. Do you follow me? Does everybody follow me? And this is actually the consequence of a FOIL. This is a consequence of a FOIL. Do you guys remember FOIL? Some of you might remember you learned in your algebra class, you do the FOIL. The first FOIL, they each represent something, right? They each represent something. What is F? F is meaning the first time the first. First time the first. O meaning what? The outside, okay? A times B. A times B. The I meaning the inside. B times A. B times A the same as A times B, yes? So the O is for outside, which is A and B. The I is inside, B and A times B. So we have AB. And L is for last. So B times B is the last. So this is also the FOIL, the consequence of FOIL. You guys follow me? FOIL. So if you forget about FOIL, I hope this will be a decent review for you. Got it? Are you guys with me? Get it? So FOIL or geometric meaning? Geometric meaning. Okay, the total area is the sum of these 4 small pieces. So far, so good? Now, okay, what we're doing, did you guys draw the picture? I want you guys to draw the picture. Could you draw the picture, please? Draw this picture because I may abracadabra, I might make it disappear. Okay, I might make it disappear. Okay, and of course, a times a is a squared, right? A times b, we have 2ab, so we're gonna combine them, 2ab, twice of it, plus what? B times b is b squared. You follow me? Does everybody follow me? Yeah. Okay, so that's a plus b squared. So now my question is, if someone tells you, or if you are the teacher, you're grading a piece of work, and this student tells you a plus b squared is equals to a squared plus b squared. Is this right? What does it tell us? Is this correct? Is the total area the same as just a squared, b squared? Obviously not, right? Do you follow me? Obviously not. So what's missing? We're missing these 2 pieces. Okay, we're missing these 2 pieces. Right? We're missing these 2 pieces. So these 2 pieces are missing. We have a squared, b squared, but a squared plus b squared is not the entire area of the square. Okay? So far, so good? Okay. With that said and done, what's the use of it? What is the use of it? The algebraic aspect of this is very useful. The algebraic aspect of this is very, very useful. Okay, so what we learn here is how to FOIL and what the geometric meanings. Okay, what is the geometric meanings? And as when we do algebraic manipulation, and this formula is often used, okay? So here we get our first formula. Okay, special formula, you might have learned this before. Okay, this is, you can find these from elementary algebra textbook. And that is equals to a squared plus 2ab plus b squared. We actually see a pattern, don't we? Do we see a pattern? So here's a, and here's b. A is a, we have a perfect square here, and we have in the middle 2 times AB, 2 times AB. So if you can identify this guy, to make a perfect square, you just have to make a 2AB. That's all that you will make that, you will make that perfect square. Do you follow me? So making perfect square is a task we're gonna be doing, okay? Sometimes we can make the perfect square. Of course, sometimes we cannot, but the cases you will be given are the cases that we can make the perfect square. Does everybody follow me? So I would like you guys to write this down. Okay, I want this picture to be on your flashcard. Could you do that for me? I want this picture to be on your flashcard. Okay, because we're gonna use this often. Okay, I'm gonna try to draw a picture within this software, and we use that during the break, okay? But anyway, are we ready to move on? Okay, this formula is very useful on making the perfect square. Now, did you write it down? Did everybody write it down? Okay, you make this square. You can use a color or you can use different colors. Okay, and then we want to look at the first column of alpha 18 in the first table, Ready? Okay, so I'm gonna clean this up. Okay, and of course we know this is false. This is false. Okay, this is false. But this is a very common mistake. I saw this mistake in classes at all levels, including calculus classes and so on and so forth. Okay, so I want to make a point out of it. Okay, so let's see how we apply this formula. How we apply these formula. Okay, the first column is all about applying this formula. For example, if you have x plus 1, what do? You FOIL or you apply the formula. So next, I want you guys to do some FOIL exercise. Could you do that for me? Could you do that for me? Please, even though the answer are all given to you, I want you to do it in class. Don't look at the answer, do it yourself. Okay, don't look at the answer, do it yourself. Okay, please do it. Please do it. Okay, so I'm gonna put these in place. Okay, how about you guys work on this? 3, 4, 5, 6. Is for each one of them. And you find a pattern, don't you? Do you find a pattern? Do you find a pattern? Do it yourself, okay? Don't look at the answer. If you get stuck, look at the answer. If you get stuck, you look at the answer. What pattern have we found? Perfect square. You FOIL each one. Tell me what pattern have you found? Doesn't do it for me. I have to do it. You FOIL every one of them. What pattern have you found? What pattern have you found? What pattern have we found?
Is it that X is A and B is 1 and B is 2 and so on?
This is 2AB, right? This is 2AB, isn't it? This is
Yeah.
2 times X times 1, right? That's 2AB, right? So if you apply the formula faithfully, what you're going to see? You're going to see X squared. What else pattern have we identified? 2 times X times 2, right? And plus what? Plus 2 squared. Okay, so I want you guys to apply the formula. So do they fall in the same pattern? And I'll be asking you some questions afterwards, okay? So you follow each one and you write them in this form. Write them in this form. Just play with it. Have a good time, okay? This is not a test. You just get familiar. Get familiar, okay? Get familiar, just like driving, right? As we're familiar with the brake and gas pedals, and we not only get our driver's license, we also can go anywhere we want with a car, right? So that's the purpose of this exercise. Familiarity, familiarity. Familiarity. Got it? Identify patterns. You certainly can make the list longer, right? But we're not going to do this forever. We just want to see what is the pattern. There is a pattern, right? What is the pattern? First number, second number. We're adding two numbers and then we square the sum, okay? This is actually called a square of a sum, okay? Square of a sum. Can you say the word square of a sum? You can even say the square of a sum of 2, right? The square of the sum of 2. A square of a sum of two numbers. That's what it is. And this is, and what does this formula means? It means you can do it. This is always true. This is the truth. These are the true statement. Truth about numbers. This is another truth about numbers. Okay, a square of a sum of two numbers. Sometimes we just use shorthand. We just say just a square of a sum. Okay, square of a sum. Okay, in the simplest form. In the simplest form. And what have we found? We have two perfect squares here for each number in the sum. And the middle term is 2 times A times B. And all of these fell into the same pattern. All of these fell in the same pattern. Okay, so now, are you done with all these foils? I'm going to ask you questions. I'm going to be asking you questions. Questions. Okay, if x squared plus 4x plus something is a perfect square. What number should be in the blank? Can you tell me? I just tell you x squared plus 4x is a perfect square. We don't know what this number is, but can you tell me what number to fill it will make it a perfect square? So this process is called making a perfect square. Making a perfect square. What should this number be? I'm waiting for your answers. I'm waiting for your answers. Hello?
Is it 2?
Is it 2? Look what you just did. If you put a 2 there, will it make a perfect square? If it makes a perfect square, what is that perfect square? Is there a way to verify? Is there a way to verify you got the right answer? If you think this is 2, will this make a perfect square? Right, so we have choice A, that a blank should be filled with a 2. Do we have another choice? Do you understand my question, right? You need to identify this number. Okay. What should that number be to make a perfect square? Okay. You are told that this is a perfect square. So what should that number be so that it is indeed a perfect square? So you need to identify the number to fill in the blank and also tell me what should it look like. Did I make my question clear? Is my question clear? Is my question clear? You just did the FOIL, didn't you? Are you doing it? You look at the notes, I have, you know, this is 2 times, that's x squared plus 2x plus 1. And 2 times x times 1, that's a 2x. And 1 squared is 1. 2 times x times 2, that's going to be 4x. And this is going to be 4. 2 squared is 4. And this is, oh, never mind. I'm gonna keep that. Okay, I want to keep that. Do you guys follow me? What should that number be? Is it still 2? Or 2 squared?
Two squared.
That's right. It should be 2 squared, right? It's right here, isn't it? Do you follow me?
Yeah.
So you were given x squared plus 4x, and you identify another number to make it perfect square. That number should be what? Should be 2 squared. Yes, not 2. Okay, so what will be that perfect square? It should be x plus 2 squared, right? So can we verify our answers right? Can we verify this? To verify what you do, you just FOIL this all over again, right? Yes? So first, plus 2x plus another 2x plus a 4, and you're gonna get x squared plus 4x and plus 4. So we found it, right? Does everybody follow me? Are you ready for another one? Given another perfect square, okay, this time is x squared plus 10x plus blank. What should the number in the blank should be? What should it be? What should it be?
5 squared.
5 squared, perfect answer. 5 squared. Excellent, does everybody follow me? And that will make a perfect square. And you can verify. Yeah, you can verify, and there are all these references, right? You can refer to the table for reference, and you can also, and we have identified a pattern, haven't we? Have we identified a pattern? From here to there, what pattern have we identified? What pattern have we identified? What pattern have we identified in order to find that perfect square? What is it? You just take the 4 divided by 2. Half of 4 is 2, 2 squared. Half of 10 is 5, 5 squared. Do you guys see that? Do you guys see that?
So it's kind of like the square root or no, never mind.
It's not square root. So what is it? Do you identify the pattern? How do we recognize the pattern? Look at the first table. Look at the table on the left. What do you see? A lot of pattern to identify, right? There's no hurry. There's no hurry. Okay, so I'm going to write this as 2 squared. Okay, so how about you pay attention to this pattern I have identified. Okay, this pattern I have identified to see if you agree with me. Okay, so this is going to be 8x. Okay, this pattern I identified is this. Okay, so let me tell you. If the last number is missing, okay, if these numbers are missing, okay, these are missing. How do you identify these patterns? You just take the number in the middle, divided by 2. 2 divided by 2 is what? Is 1. And then you put a square. And the second box, okay, I'll just take the 4 divided by 2, and that's 2 squared. Do you follow me? Do you think this pattern I just identified works for all of them? One is half of 2, 2 is half of 4, 3 is half of 6. Does this pattern work?
Yes.
Does it work always? That's the question, right? Does it work always? Because we only have dealt with 9 of them, right? It works for 9. It doesn't mean it's going to work for all of them. Yes? Of course not. We cannot use 9 examples to infer it's going to work forever. Yeah? We have identified a pattern, but we need to verify that. Okay, half of 8 is 4 squared. Does everybody follow me here?
Yes.
Half of 10 is 5, 5 squared, yeah? And this one over here, I'm going to put it here, right? And this is going to be 6 squared. You can keep going, yeah? Does this pattern work for all of them? And it's all in this formula, don't you see that? A squared plus 2ab, okay? If you put an A in front, times 2b, 2b, b, 2b, b. X matches, this is the axis. Do you guys follow me? Do you follow me? X squared, if A is X, this is X. You can see that. X, X, A, A. So this is 2b, and that's B. Do you guys see that? So this pattern we just identified works forever. It's because of this formula. Does everybody follow me? Yeah?
Yes.
Everybody? How come I only hear one voice? Can we have more voices? Well, this is too simple. Do you guys see that? We're just identifying the patterns. It's a simple formula. We identify the patterns and then you say well, what to look for, right? What to look for. The first thing we look for, we found there's a pattern. Provided it is a perfect square, of course, right? If it's not a perfect square, of course, you can go wild. But provided it is a perfect square and two numbers involved. So what are the patterns? Look at this pattern. Look at this pattern, right? Look at this pattern. In this case, right? A is X. Hold on. A is X, B is 1. So this is A is X, A is X, B is 1. Okay, B is 1. Okay, so 2 is twice of 1. Yeah, so this pattern works forever. Do you follow me? All right. So this pattern works and it works forever, provided it is a perfect square with two numbers involved. Can we move forward? Now, does it work for 7? What would it be? Does it work for 7? Of course, this is gonna be 7 squared. And this is gonna be what? And what we really recognize here is this 8 is half of 16. It's a half of 16. You guys follow me? This is 14. You follow me? Last but not least, does everybody follow me? Sorry, I'm missing the axes, and this is the last one. Last one in the table. Okay? So 6 is half of 12. 5 is half of 10. Does everybody follow me? Are we good? So now I'm going to ask you more questions. Okay?
I'm good, Professor.
I'm sorry?
Oh, no, that I'm good, Professor.
Okay, good. Okay, so now I have x squared plus 16x. What should be in the blank to make a perfect square? And what is that perfect square? How do you make it? Francisco, can you give me that number? Does everybody get it? So Marcelo, you said you got it. So can you tell me what that number should be to make that perfect square? Marcelo, thank you for your feedback. What should that number be? What should this number in the blank should be? Right? What should that number be? X plus 4. This number should be x plus 4. Where do you mean x plus 4 should be? I'm asking the blank. I'm asking what should be in the blank. Okay, you mean this one, it should be x plus 4. Okay, but what should be here?
X to the power of 2.
I'm sorry?
4 to the power of 2.
4 to the power of 2. Perfect. You got it. I really do think you got it. Does everybody follow me? Now I'm going to give you a harder question. Okay, very good job. So this time, you're going to make that perfect square for me again. Whoops, x squared, okay? Plus 20x. What should be in the blank to make what perfect square? This is not in the table, right? This is not in the table. Yeah? What should that number be? You're probably busy verifying, right? Did you get it right? Yeah? You want to think about it? How about we take a break? We'll come back to it. Okay.
Yes, please.
What number is it? Do you find it? What should that number be? Or should we take a break? We think about it during the break? Yeah? Shall we? All right, let's take a break, right? You must be tired. Let's take a break. Come back at 11:52 and we will continue. Okay? You can think about it during the break. Okay, was 4 correct? No, 4 was not right.
I thought it was 8 squared, but I don't know.
It's 8 squared. It is 8 squared. It's not 8. I'm sorry. I obviously needed a break. Okay, 8 squared, half of 16. So you guys see that? 5 is half of 10, 5 squared. 2 is half of 4, 4 squared. 5 is, are you guys with me? This is repeats. So what should this number be? Come on, guys. Would that be half of 20? 10 squared? Where is everybody?
10 squared would be 100, wouldn't it?
Yes, 10 squared is 100. Is that okay? Does it work? We can always verify it, right? So you project a number and we can verify that, can we? And you just take x plus 10 squared, you FOIL, what do you get? Huh? What do you get? What do we get? Could you FOIL that for me? Yes? Does it work?
Oh, it does work.
Good, I'm glad. I'm glad to hear that. Did everybody get it? Could you do this on a piece of paper because I have another question coming. X squared plus yeah, 26x plus blank. What should it be in the blank to make what perfect square? Okay, I'm gonna give you a few more. 64. 144. Last but not least, 4 questions for you to answer. What should be in the blank to make that perfect square? Did you write it down? Could you please write it down? Yeah? All right, did you find the numbers? Okay, I'm gonna call this the number 1. Give me the answer for number 1, 2, 3, 4. You need to get this, okay? This week, there'll be quizzes on these. Making perfect square. Making perfect square. You're probably busy verifying, right? That's very good. Verifying those. Okay, everybody. Could I expect some answers? Stephen? Stephen, please. Do you have the answer to one of them? Do you have the answer to one of them?
No, I do not.
Huh?
I don't.
You don't?
Nope, still working on it.
Is the first one 13? I'm sorry, 13 square?
That's right. You just take 26 divided by 2, it's 13. You don't have an answer to it. Maybe you didn't get what we have covered, right? Yes, Stephen, do you have a question? Are you with us?
Yeah, I'm doing like another thing right now, but
Marilyn, did you contribute that answer? I didn't know who gave me the answer. 13 squared. What is it, Brianna?
What happened?
Who gave the 13? Who gave the answer 13 squared?
Oh, that was.
Who is it?
Oh, me, Marilyn.
Okay, Marilyn. Thank you, Marilyn. That's a good job. So what is the perfect square? It's x plus 13 squared, yeah? Yes? How about the second one? Alan?
32.
32? That's it. That's not right. You're missing something.
32 square.
32 squared. That's right. Don't forget the square. If you don't have that square, it's not going to make it. So what is the perfect square? What is in the parentheses? Ellen, you can complete that.
X plus 32.
Perfect. X plus 32. Wonderful. Can we verify? We can verify each one of them, right? No, let's look at the number 3. Let's look at number 3. 144. What is a half of 144?
72.
72. So what number should be in the blank?
72 square.
Perfect. The last one. What should that number be? What number is in front of X? What number should be in front of X? Oh, wait, we need to complete this one. X plus 72. Right? What number should be, what number is in front of X? It's 1, right? Isn't it?
Yes.
What is half of 1? What is half of 1?
Is it 0.5?
It's 0.5. It's half, isn't it? So that's going to be half squared. X plus half. Could you guys verify each one of them? So now please verify. Okay. So I just drew this little square for you. Let's see how we use it. Let's see how we use it. For example, for number 4. Right, for number 4. How do we use this little square? Right, how do we use this little square? Obviously, A, this is X, right? X times X, right? You follow me? And we don't know what this is. Okay, this is a question mark. We don't know what it is. So A is X. We don't know what is B, right? We don't know what is B. A is X. We don't know what is B. But we know that this A AB plus AB is X, right? Since since X is A, so X times B, 2AB, is 2XB, yeah? 2XB is X. Yes? Because you're matching this X here, right? We're matching this X here, yes, don't we? We're matching this X here. So 2B is 1. Do you follow me? So 2B is 1. If 2B is 1, B is what? B is half. If you like to use this little chart, okay, some people like to use the chart, but some people you just take whatever this number in the X and divide it by 2 and square. That's it. This formula tells us exactly that. Do you follow me? So let's revisit this formula one more time. Okay, this formula now should look what? Should look different to us. Okay, suppose I take this away. And here you have a 2AB. 2AB. What should be in the blank to make that perfect square? You guys, what should be in the blank to make perfect square? A matches A, we have a 2B. Half of 2B is what? It's B. B squared. Does everybody follow me? Yeah? Or am I spending too much time here? Trust me, I hope this time is not wasted because we have, in the past, a student have lots of hardship with this. That's why I decided this semester I'm going to take a different route to cover this. Does everybody follow me?
Yes.
Okay. So you understand everything so far, right?
Yes.
So now let's look at the second column of alpha 17. We have a minus. We have a minus. Okay. So to deal with the minus, okay, after we're done with the plus, I wish you guys to FOIL this guy. Could you FOIL A minus B squared? Please FOIL that. Please FOIL that. Okay? What'd you get? What'd you get? You get that? Yeah? So next, I want you to do another table. Oh, sorry. I'm trying to highlight it. Oh, sorry. Okay, try to highlight this. Plus turn into minus. Plus turn into minus. So A minus B. If you FOIL all of them, what you get? I want every one of you doing this, okay? Please, okay? This may be too trivial for you, but you might learn something from this experience. I assure you, you might learn something from this experience, okay? So this time it's not sum, it's a difference. Square of difference, and you will find these patterns. Okay, you'll find these patterns. That's the only change. That's the only change. Do you agree? Do you agree? I'm going to be asking you a question again, okay? I will be asking you a question again. You should expect a quiz either today or tomorrow about these, about making perfect square, okay? You have to identify the number in the blank and make a perfect square. Okay, are you ready? Are you ready?
Yes.
Take your time. Okay, ready. I'm glad. All right, making perfect square. I have a x squared minus 12x. What number should I be putting in the blank to make what perfect square? Okay, one more. I'll give you a couple more, okay? X squared minus 18x plus. What's in the blank equal? It will make what perfect square? Okay. And the other pattern, okay, I'm gonna give you two more, okay? Minus 4x minus what number to make what perfect square? Okay, so make perfect square if possible. Okay, there's an if. Last but not least, 4 questions. Minus 3x plus blank. To make what perfect square? I know we're going pretty slowly here, okay? Some of you may be bored. I'm sorry, but, okay? Don't estimate the importance of this part. In the future, when we do, more completing perfect, making perfect squares, you may have to come back to this lecture to do it again. Okay, we're laying foundations for the future, future stuff. So 12x minus 12x. You see, I have a title here. Make perfect squares if possible. If possible. Just 1 second, okay? I'm gonna wash my hands. All right, I'm back. What is the first number? Yeah?
Is it 36?
36, perfect. And what will be the perfect square on the other side? Half of 12 is 6. 6 squared is 36. Okay, so you can either put 36, you can put 6 squared. So what will be the perfect square on the other side? X. So what should be in the parentheses?
X minus 6.
Perfect. X minus 6 squared. Perfect. Okay. Now, the second one. What number should that be? Yeah? What should that number be?
Is it 9 square or? Well, I don't know. It's kind of hard.
You have the right answer, but you're not confident about it, right?
Yeah.
You're right, 9 squared. You just take 18. You see, with minus, everything the same when you were doing the squares, right? Except, right? Plus 1 squared, plus 2 squared, plus 3 squared, everything the same. The only thing that's different is the middle part, right? Negative turn into negative, negative turn into negative. And previously we had positive, right? You just observe the pattern. Don't you see that? You write it down on your paper, right? So this is what will be in the parentheses here.
X minus 9.
That's right, X minus 9. Can you verify? Can we verify, right? If we're not sure, we can always check, right? And as long as we know how to check it, and we can always have an answer, we can verify whether we got it right or wrong, right? So can you verify these? Can we verify these? It's just X minus 6 times X minus 6, right? When you FOIL this, are you gonna get what's given? And after you filling up with filling in the blank, what do we get? Yeah, what do we get? X squared minus 6x minus 6x plus what? 36, right? Does it make it?
Yes.
See, we have more confidence now?
A lot more. Yay.
Okay, good. I'm glad to hear that. Now, the third one. The third one. The third one. Make perfect square by subtracting a number in the blank. You can try and verify, right? We can always verify. How about the last one? Third one and the last one. Okay, so that's answer number 3. Anybody?
2 square.
2 square? Is that what you're saying?
Yup.
All right, what's in the parentheses?
X minus 2 squared.
X minus 2 squared. So did you verify?
Yup.
What did you get?
You'll get X squared minus 4X plus
Go on. What you get?
4.
You get plus 4, right?
Yep.
Are these two the same?
Yep.
They're the same. This is -4. This is +4. Are they the same? Hmm? -4 +4, are they the same? Did you find the match? This case is impossible. Okay? That's why I have the word if possible. Sometimes it's not possible. When you subtract, you will never make a perfect square. Okay? So not possible. Okay, you can verify all you want. You can try any number you want. Just by subtracting, you never make it. Is that clear? Everybody?
Yes.
You can keep trying, okay? And the reason I give this question, I want you to notice on both columns of A plus B on alpha 17, okay? It's all about plus. Perfect square are always adding. There's no subtracting. Do you see subtracting? No subtracting. In the second one, there's adding 1 squared, adding 2 squared, adding 3 squared, adding 4 squared, adding b squared. Okay, where is it? Where did I put it? Here. Adding b squared, not subtracting. Are you guys with me? Did you notice that? When you have a plus b squared, okay, this will be plus. But here it's always plus b squared, never subtracting. Do you follow me? Did you follow me?
Yes.
Okay, so these are little details, right? Right in front of our eyes, but do we see it? I would say sometimes we do, sometimes we don't. Yeah? Sometimes we see it, sometimes we don't see it. Okay? So sometimes when I was a student, I like to memorize these formula. I don't know if this will work for you. I like to memorize these formula by just one simple form. Okay, I like to memorize these two formulas just by this simple form. This is a plus minus and this is plus minus. Everything else stay the same. Okay. Do I need to memorize this formula? I don't think so. I don't need to memorize this formula. I hope you don't need to memorize these two formulas either. But if you try to memorize this, then you need to know this is plus. The plus corresponds to the plus and minus corresponds to minus. And the last term is always, always, forever plus b squared. Do you follow me? Always. Now let's look at the last one. So this third one is impossible. It doesn't work. Okay. Doesn't work. It will never work. Okay, trust me, you can keep trying and come back to me. Okay, tell me if you find something work and let me know. The last one. What will be the last one? What should be in the last one? My quizzes will cover all of these different aspects about perfect square, about making perfect square. Yeah? So what should that number be?
Is it 1.5?
125?
No, 1.5.
1.5?
Oh,
That's
1
it?
square.
Huh? Just 1.5?
No, 1.5 square.
That's right. Perfect. Perfect. Okay. Or may I suggest another form? 3/2. 3/2 is 1.5. So your answer is right. Your answer is just as good. Okay, so I'm going to give you two forms of answers. Okay, 1.5. Perfect. So what is on the other side? What's in the parentheses?
X minus 1.5.
Yep. X minus 1.5. That's it. Or X minus 3/2. Okay, so can you verify these for me? Can you verify right now? Right here, right now. Verify, please. Verify, please. Did you get it? I'm going to put the work under. Knowing you don't like fraction, I want to challenge you to do some more fractions. Verified, verified. Are we good? Are we good? Yeah? Are you ready for some more questions? Are you ready for some more questions? Do you think you got it? Do you think you got it? If you got these, I think I'm ready to give you some more questions. Ready? Yeah? These will be a little bit more challenging. Okay, these will be a little bit more challenging, but I think you can handle it. I think you can handle it. 4x squared minus 4x plus what to make a perfect square of what? What we have seen so far, there's just x squared on the first term. Now I have a 4x squared. Okay, just to remind you, all of these are from the same source. Here. If you think you got it, okay, let this question challenge you. Let this question challenge you. So let's see what do we have. What have we found? Yeah. What have we found?
The 4 is confusing me.
How does that confuse you? Okay, we're running out of time. Let me just give you some
Would it be 2 squared?
2 squared. What do you
Like-
mean 2 squared? 2 squared here?
Yeah, like right there.
Does it make it? So what is that? What's the square of what?
It'll be 2x minus 2.
2x minus 2.
Yeah.
Did you try it?
I tried verifying it and I got +4.
It doesn't
I
work.
got,
It's not gonna work.
yeah.
Okay, it's not gonna work. Okay, so let me show you how I see this. Okay,
All right.
it's not gonna work. 2x squared. Okay, 2x squared. You need to remember the source of all of these is from here. You follow me? This is the source. Okay, I'm gonna remove this just to keep it simple. How about that? Yeah. So what you have here is 4x squared, and you have to identify the a. In this case, you have to identify both a and b. Okay, that's the challenge. 4 is 2 squared. So 4x squared is really 2x inside the parentheses square. So your a is no longer just x. Your a is 2x. Do you follow me? Do you guys follow me?
Yes.
Okay. This is the 4x squared. Are you with me? This is 4x squared. Now you have a minus 4x, right? Minus 4x can be written as 2 times 2x times 1, right? So this is a 2 matches the 2, a matches the 2x matches the a, b matches the 1. Do you follow me? It's really a matching game. Does everybody follow me? This is a. This is a. Okay, let me box it. This is a. This 2 has to be there. B has to be 1. So the number that should be in the question mark is really 1 squared. Okay, so in this scenario, you not only need to identify A, you not only need to identify B, you need to identify A as well. Do you follow me? In all of the examples we did above, A doesn't need to be identified because you are given a perfect square already. Yes? So A is X, you don't have to worry about it. But in this case, however, you have to identify the A. How do you identify the A? 4x squared, if you write it in a perfect square, it's 2x squared. And therefore the B is gonna be what? 1 squared, 1. And this will work. Would you like to verify that? Would you like to verify that? Yeah? Could you verify that? And last but not least, I want you to do one more. Okay. So you got that, right? This time, I'm gonna give you 4x squared okay? Minus 12 x times y plus what to make a perfect square of what? Maybe I will give you an easier number. Okay, so 2 times. Yeah, that should be pretty straightforward. Right. So you need to identify the A and you need to identify the B. And this is a minus, so you can use this formula directly. Okay, I'm gonna even switch it to make it easier for you. To see if that helps. Play that matching game. You're probably tired by this time, right?
Professor, can I guess?
Sure, do that. I like it. So what should that be?
I feel like it's 6xy squared.
In the blank?
Yeah, in the blank.
6xy squared?
Yeah.
You're saying?
Yes.
Did you verify? So what should be in here?
2x minus 6xy.
So did you verify? You're very close, but it's not. Okay, let me show you how to do it. Okay, we're running out of time. We have 1 minute. Okay, I may take a little bit more time. Okay, are you ready?
Yes.
Okay, we don't know what it is. This is. Okay, so we know how to deal with the 4x squared, right? So that's a 2x squared. Okay, so we need to make the 2ab, 2ab. A, we already know the a, yeah? A is 2x. Okay, so we need to make a 2ab. 2 times a, that's a. The question is, what is b? Yeah? Yes? 2a b. What should we be b? Right? And this whole thing has to be 12, isn't it? Right? I give you 12, right? What I give you was a 4x squared minus 12xy plus and something blank. Is that right? So now I'm working it. This is my 4x squared. And this piece has to be 12xy. There should not be any alteration. I just break it apart. Do you follow me? So what should be the capital B? Have you identified the capital B? 2AB. Do you see it? What should be capital B? It's a 3y, isn't it? Do you see that? Do you see that? So what's in the box should be 3y to the power 2. You're pretty close, okay? So that perfect square should be 2x minus 3y. Okay? And you go home, verify it. You are at home, okay? So after class, verify it, okay?
Okay.
You're close. Very nice try. Very nice try, okay? I will see you guys on Wednesday, if not sooner. And do review this part, okay? This part is not that trivial as you might think. This is actually elementary algebra we just did. This is elementary algebra, okay? All right, if you need more exercise, and you can find the elementary algebra textbook to get some more exercises. But if you practice what I have given you really carefully, okay, you will get it. Okay, I didn't really give you a lot of assignment for this in the notes because I thought I would just go over it. You guys will get it. Obviously, we need some more practice. Okay, but we have covered everything I think is necessary for us to get this understood and being proficient. But to be proficient, we need to practice. So I will be preparing some quizzes for you in this part based on what we've done today. Okay, I'll see you guys tomorrow. There's a chat message. Okay, Marcelo. Okay, thank you, Marcelo. Thank you. I will see you guys on Wednesday, if not sooner. Okay.
Professor, do we have any homework at least?
I did assign you homework. I want you guys to practice Alpha 17A. Alpha 17. Okay, what we have done today in class and look at the patterns and stuff like that.
Oh, okay.
That's the homework. Okay, so it's not, it's not, but if you feel you need more exercise, then you may like to just pick up any elementary algebra textbook to go to there's a special formula session. Okay, so this material can be found in any elementary algebra text. Okay, look for the sections titled special formula. Okay, typically in the chapter of factoring. Okay, I don't know which chapter because I don't know which textbook you're looking for. Okay, very good job, very good participation. Okay, I hope that helps. All right, I will see you guys on Wednesday, if not sooner. Okay, you're getting it. I'm happy, I'm pleased. Okay, good job.
Okay, thank you, Professor. Have a nice day.
You too, Marilyn. Bye-bye, everybody.